Hello, everybody, and welcome back to Creation Myths. First, I need to make sure everything is working on YouTube, and then we'll get going with what we're talking about here this evening. Chat, you know the deal. If there's any problems with the audio or the video, let me know, and I will try to address things as I can. But I'm just currently just going to wait a second to see if I can make sure everything looks okay on YouTube. And it does look okay on YouTube. Great. So let me go back to this. We don't need this up. I'm going to come back to that later. So let's see. I can see me. I can see my little screenshots there. I just want to make sure everything's good. Hello to, looks like Simon Reed's text, Dapper Dinosaur. Great to have you here. Yeah, we're doing a live show on a Thursday, which is weird for me. I'll explain once we get going. So let me just make sure that everything looks okay, video quality wise and everything. Not that long ago, just a little bit of a peek behind the curtain. Like half an hour ago, I did a little 5-minute technology check because I'm in a new location. I'm in my attic instead of my basement because I'm in the process of relocating my office. So what happened when I did that technology check was my video quality suddenly got really good all of a sudden, and I don't know why. So I'm just going to futz with my monitor for a second, which is where the camera is. And what happened is I tilted it up and I tilted it back, and then it got really good. So you know what? We're going to see if that works again. And if it does, I will be very happy because it seems like the amount of light plays a significant role in how StreamYard likes to handle my video. So we're going to see what happens. But chat, you let me know if the video quality seems like a problem, or if it's just regular meh. And obviously, if the audio is having issues, let me know. I want to recognize that the audio is a little echoey in here. I haven't figured that out yet, but part of what we're doing here is I'm just kind of seeing how things work and, going from there. So here we are. So what are we doing here? Why am I doing a live video on a Thursday night? My nights, Dan, your nights are Wednesday nights. Why are you doing a video on a Thursday night? So here's the backstory. As I record this, it is June 11th, 2026. On June 10th, 2026, I released a video about baraminology in response to a video by Dr. Matthew Cserhati. This video was specifically about viruses and how the fact that viruses exhibit separate ancestry, very clearly exhibit polyphyly, is very strong evidence for the monophyly, the common ancestry of all cellular life. That was the gist of the video I previously released, and because I am a professional, I will remember to link that video in the description after I get off of this. So that's kind of the background here. Cserhati, who was previously affiliated with CMI, I don't know if he still is. His contributor page from CMI is gone, but it used to be there. So I don't know what the deal is there, but he used to be affiliated with CMI. He's a young Earth creationist. He has a PhD in bioinformatics, so it's not totally unrelated. So he did this video on virus baraminology, and then I was like, hey, viruses are a great example of how we know that cells have common ancestry, right? Because we have these other things that clearly don't. Right? Viruses have all these characteristics that show separate origins, and cells don't have any of that stuff. They show common ancestry, right? And now Cserhati, just like today, released a video on my video. So we're apparently doing this back and forth thing. Why not? I will say that I've relatively recently exchanged emails with Dr. Matthew Cserhati and invited him to come on to talk about this specific topic, and he was not interested. And I would say, Matt, if you watch this video, I think there is some degree of talking past each other, as I said in our emails, And it would be easy to remedy that if we were to talk face to face, right, electronically. So I want to just make sure you know, Matt, that the invitation is still open and you should respond to my email in that same email thread if you want to come on and we can talk about the evidence for common ancestry. So just want to make sure I say that up front. The invitation is on the table. Dr. Cserhati has so far not been interested, and I'm hopeful that he might change his mind because I think this would be an interesting topic to talk about with someone with a PhD in a biological sciences field who is a young Earth creationist, right? So just want to throw that out there. Okay, so let's talk about what we're doing here. The point, as I said, is that viruses are just a beautiful example of a group of organisms that exhibit separate ancestry, right? Viruses are polyphyletic. There is no single origin for different groups of viruses. There are multiple independent clades of viruses, and we know this based on things like their genomic architecture, the lack of homology of genes across diverse groups of viruses, and most importantly, if you try to do phylogenetics on viruses across all these different groups, it is a giant mess. You can't do it. Like, it literally doesn't work, right? And that's like the thing, because when you do the same techniques to cellular life, you get a nested hierarchical pattern of similarity up and down the tree of life, right? And I don't particularly care for that phrase, but you all know what I mean when I say tree of life, right? So you can do this for all mammals, all chordates, all animals, eukaryotes, and all cellular life. Depending on what parts of the genome you compare, you get a nested hierarchical pattern of similarity, and that is not something that is compatible with separate creation. Specifically, that pattern in unconstrained regions of the genome, which is to say regions of the genome that are not subject to purifying selection. I've gone into this in so much detail over the years. I'm not going to belabor the point here, but that's like the basis of what I'm talking about, right? So now what I'm going to do is pull up just some screenshots of this video from Dr. Cserhati. His slides are entirely text, which, you know, that's a choice, but okay. And I just want to point out some of the problems here. So here we go, folks. Let's do it. Here we go. Okay, so this is the video that he put up. It's called Viral Barrowmans Part 2. Dan Cardinal misrepresents my work. Viruses don't prove common ancestry. And I just want to start with this. It's petty, but it's not petty. Like, I am not hiding my identity. Anybody can Google me and you're going to find, like, me, this channel, my name. My name is Dan. My last name is Stern Cardinal. It's 2 words. There's no hyphen. Stern Cardinal. It's not hard to find. You can find, like, my university faculty page with, like, 5 seconds of Googling. And I know it's complicated in that 2 words, no hyphen is not a common form for a last name, but like a little professional courtesy, get my name right. Like, just saying, I don't think that that's too much to ask. Like, let's just start there. Okay? Like, let's just start there. But okay, so I apparently misrepresented his video. I don't think I misrepresented his video, but I'm going to go through his slides here, and we're gonna see exactly what the problem is here. So let's go to the next one. So introduction. So the first thing is he said this was unprofessional, that I said that Dr. Cserhati is not just one of those creationists who's talking out of his whatever, because, like, okay, let's just be clear. Most professional creationists are talking out of their asses, right? Like, they're not experts in the field in which they speak. And Cserhati, like, he's got a PhD in bioinformatics, so, like, that's closer than most professional creationists. So I'm trying to give him credit here, and he didn't like that apparently. But okay, fine, whatever. The title of his talk is very misleading. I've only shown that viruses don't form kinds the way cellular life does. And yeah, which is to say viruses have separate kinds. It's not the right word, but whatever. And cellular life doesn't. He basically what happened here is for a lot of this, I don't think Dr. Cserhati understood the argument I was actually making, and this is my big thing for creationists. If you are going to respond to me when I make this argument based on phylogeny and nested hierarchies in unconstrained regions, before you respond to me, is it so much to ask that you understand the argument that you are responding to? Because this is a thing that happened, for example, when I debated Dr. Jerry Bergman earlier this year. I made the same type of argument, and most people who were watching, who commented, did not understand, what the argument is. And I know for a lay audience, it can be a complicated thing to follow. For someone with a PhD in bioinformatics, I don't think that that's a valid out, right? I think it is an understandable kind of argument that I'm making here. So he thinks that my argument is, well, viruses have multiple independent origins. It doesn't follow that therefore cellular life has a single origin. It's not viruses are separate, therefore cells are single. That's not my argument. My argument is that viruses meet all the predictions of things that are separate, right? If you have separate origins, you expect a bunch of things to be the case. For example, they don't form a nested hierarchy. They use different genomic architectures, right? Single-stranded versus double-stranded DNA, DNA versus RNA, single-stranded versus double-stranded RNA. That's what genomic architecture is. Cells, on the other hand, don't exhibit any of that stuff. They form a nested hierarchy. They use all the same genetic material. All cells use double-stranded DNA for their genomes, right? So the argument is that here we have an example of things that are clearly polyphyletic, right? Multiple independent origins. We can use that as a null hypothesis to then evaluate cells. And cells look different. They don't have any of those characteristics that point to multiple independent origins. Therefore, viruses inform the conclusion that cells have universal common ancestry, right? That's the argument. That's not what Dr. Cserhati is articulating here. So again, my conclusion is that he did not understand the argument I was making, right? So then these last two here, did he read my paper on prokaryotic viruses? Did he read my paper on the gene content method? I, in my video, did not talk about Cserhati's methods other than to say the following. Very early in the video he's responding to, I said, the question of created kinds is a very easy one to answer, right? What you need to do is look for nested hierarchies in unconstrained genome regions. That's how you answer the question. To the extent you find those patterns, that's a single created kind, which is to say that's a group of organisms that shares common ancestry. That is a fairly straightforward thing. I then said, the next thing I said was, Dr. Cserhati is not doing that. He's doing a kind of similar thing. He's gesturing in that direction by doing genomic comparisons to try to find the bounds of created kinds. And to his credit, that's good, because most creationists are not even grappling with that question even a little bit, right? But I was very clear in saying, here's how you answer this question. He is not doing that. And then after that point, I went on to talk about using real biology, not creationist fanfic, like how you know that viruses are separate ancestry and cells are common ancestry, right? So the whole thing, the problem that he has, where he's saying, oh, it said this, that, the other thing about my methods, he doesn't understand my methods, didn't read my papers. I wasn't talking about your stuff, dude. I was not talking about Cserhati's work. I was talking about how you do it in real biology, right? How you look at common ancestry and construct phylogenetic trees in real biology. So all this stuff about, did he read this? Did he use my methods? Whatever, irrelevant. Wasn't talking about it. Wasn't talking about you. Dr. Cserhati was not talking about you. Okay. So then we get to some stuff here that's really interesting, just in terms of viruses, because just a bit of background, my doctoral work is on viral evolution. Like, this is my thing. Like, viral evolutionary dynamics are my thing, right? So, and like, inherent to that is, where do viruses come from, right? Like, they're obviously polyphyletic. Okay, where did they come from, right? So he has this slide, what are viruses? And this is just amazing to me. This first line is incredible. Viruses, as we all know, originate from cellular organisms. Do we? Do we all know that? Because I don't think we do. I don't think we do at all. In fact, I think viruses have, like I said, multiple independent origins, and many of those I think were present as kind of replicating systems around the same time that cells first appeared. Because as far as abiogenesis goes, I'm a metabolism first guy. So I think you had just these kind of replication cycles that were occurring in the absence of lipid enclosures. And then viruses are an example of like a subset of those processes that got encapsulated in polypeptides. So I think those, some of those entities actually are at least as old as cells and did not come from cells, even if they did come from the same pool of replicators. Other viruses, I think there's very clear evidence that at least one group of viruses evolved from plasmids through horizontal gene transfer and acquisition of a capsid protein. And then, interestingly, on screen right here, I think this is really interesting because I think some viruses did originate from cellular origins. And in particular, it's this group right here, the nucleocytoplasmic large DNA viruses, the NCLDVs. Those viruses in their very large genomes, some of them over 1 megabase, those viral genomes actually contain genes that seem to be homologous to members of all 3 domains of cellular life, bacteria, archaea, and eukarya. So that would imply that the most reasonable explanation is that that one group of viruses is kind of a degenerate or reduced cellular organism. But that is a far cry from all viruses. And as I said in my video that he's responding to here, different groups of viruses have non-overlapping sets of genes, right? So you can look at one group of viruses and say, hey, look, here's genes that appear to be homologous with cellular genes. So either that's common ancestry or horizontal gene transfer. We don't know which necessarily. But there are other groups of viruses where that's not even an option, right? Because they just have completely non-overlapping sets of genes, and it's completely unreasonable to think that those groups of viruses originated as some form of cellular life, right? So I don't know where he gets this, but that is just all kinds of wrong, right? Like, I don't even know what to make of that. It's just silly. Okay. And then he gets into the methodology, and he says that I apparently seem to rubber stamp his method of analysis, which what he does to determine kinds, which is not a real thing, is the gene content method. He looks at overlapping sets of genes and says this group shares this genes, and therefore they're the same kind. This group has a distinct set of genes. They're that kind, right? I don't endorse his methods. I think he's misunderstanding the argument I was making. But again, early in my video, I said, here's what he does, which is not what I think you should do, but like, credit where it's due, it's closer than most creationists. And then I went on to talk about the real thing. But I wasn't talking about his stuff. So I was not endorsing his methodology at all. What I was talking about was the real way you do this is looking for clades in nested hierarchies when you do phylogenetics, which I want to remind everybody is a technique that has been experimentally validated. That was Hillis, I want to say Hillis 1991 was the paper, where they evolved lineages of bacteriophages in the lab and then sequenced the descendants and did the phylogenetic methods and basically reconstructed the evolutionary history. So you have experimental validation of the phylogenetic methods, right? Those are the methods that I'm talking about. In that paper that I referenced, the Hills paper, they did use neighbor joining, not endorsing neighbor joining. But the other ones, things like maximum parsimony, maximum likelihood, like those are totally valid phylogenetic methods. If parsimony is a little bit simplistic, okay, it's still okay. And when you do that for real, you get, to be clear, you get separate clades for viruses that are independent of each other, so no common ancestry. And then for cells, you get a single clade with common ancestry, right? Like that's just how you do it. And that's what I was talking about. I was not endorsing his methodology, right? That's just how it is. Like, I don't know what else to say to that. So I think we can move on. So he gets to his conclusions, and he says, apparently didn't read his work on prokaryotic viruses, which is to say bacteriophages, that's viruses that infect bacteria, or the gene content method. No, sir, it's not that I didn't read your work, it's that I wasn't talking about your work, which are two different things. He makes faulty non sequitur conclusions. You misunderstood my argument, Dr. Cserhati. The argument that you said I was making in the beginning here that I showed, it's not the argument I was actually making. He seems to agree that the gene content method is useful. No, that's not what I'm saying. I'm not saying that's a valid way to determine kinds. I said, here's how you determine kinds. Dr. Cserhati is not doing that. Here's what's actually going on. And he uses a tool of baromenology to find different baromins. No, I'm not, because I'm not using his gene content method. I'm talking about doing phylogenetics the real way, using nested hierarchies and branch support as you build your tree with increasingly broad data sets of sequences. And at some point in viruses, the branch support collapses and you're unable to build a nested hierarchical phylogenetic tree. In cellular life, that is not the case. You can go from animals, you can go from mammals to bacteria, and you can construct a nested hierarchical pattern of similarity phylogenetically. That's the technique I was talking about. I was not talking about baromenology and the technique that Dr. Cserhati wants to use in the context of baromenology. So the takeaway there is that I don't think he actually understood the argument I was making. So, I don't know. But to reinforce what I said previously, viruses are great because they clearly exhibit separate ancestry. And if we look for those hallmarks of separate ancestry in cellular life, things like different genomic architectures, completely non-overlapping sets of genes, and the lack of a nested hierarchical pattern of similarity, we find none of that stuff in cells. Instead, cells exhibit the opposite, right? There's a core set of genes that cells share, things like ribosomal DNA. There are a nested hierarchical pattern of similarity in genes and unconstrained regions. And by the way, that's another hint that I was talking about a different methodology. I specifically referenced unconstrained regions. Meanwhile, he's comparing genes, which are highly constrained. So obviously, I'm talking about a different thing. And then, so it's the non-overlapping sets of genes, the differences in genomic architecture, and the nested hierarchical pattern, present in cells, absent in viruses. Those are the things I'm talking about. And the key one, the most important, the thing that I lean on all the time is the nested hierarchical pattern in unconstrained genome regions, right? And it is mathematically, literally mathematically impossible for common design to explain the pattern of similarity in those sequences. And I would love just once for a creationist to try to explain that with something other than God could have done it that way, because that's always where the answer goes. So I think that's where we can leave this one, except for a couple of programming notes. So what I was planning to do, completely independent of this little back and forth with Dr. Cserhati, is take a piece of what I did in class just recently for my evolution class and ask the question, what counts as living? What is alive? What does that mean? And where do we draw the boundary between living and non-living? And I'll do that as a live show at some point soon because in order to make that work, it's going to be highly interactive. And so, chat, you're going to have some questions to answer when we do that because we're going to play a little game and it's really fun. And then what I'll do, because a bunch of people in the comments of the video that I published yesterday, again, currently June 11th, so I'm talking about my June 10th, 2026 video. Several people in those comments said, hey, it would be really cool to get like a longer version of this, talk about viruses and separate ancestry and all that stuff. So I think I will do something like that, kind of an expanded version of that, showing like, here's all the reasons that we can tell viruses have separate origins, and then cells are not each of those reasons, right? They actually show common ancestry for each of those kind of characteristics. So those are things that I'm planning that are related to this topic coming up. So yeah, I think that's where we can leave this one. Thanks, everybody. Thank you for joining me in the new digs. I hope the video quality and everything was more or less okay. I'll continue to work on things as I get, kind of situated here and get everything set up. But I think that's where we can end this one. Thanks, everybody. Please remember before you leave to do the various algorithm-friendly activities. If you haven't hit the like button, please hit the like button. If you're here and you're hanging out and for some reason you're not subscribed, please hit subscribe. Feel free to share this video. Yeah, that's where I'll end it. Have a great night, everybody. As always, don't get fooled. I'll see you next time.